Good morning, guys. Um, let's talk about chapter 7. Chapter 7 is something about exponential functions. It's quite simple. You just need to understand what's the difference. So I'm going to tell you about the difference. Let me give you the first scenario for this one. Let's just say that one day you make $100. So if one day you will make $100, on the fifth day you will have made $500. So on and so forth, 600. Okay, and this function, let's just talk about that. Um, this is talking about a box, and then x is the length of a cubic box. So if it's 2, what is the volume, right? 2 times 2 times 2, because it's a cubic box, it will be 8. If it's 3, it will be 27. So on and so forth. 4 would be 64. Next, this is something called the exponential function. You see that this time, the x is in the exponent. It's quite simple. Let me give you this scenario, okay? Think about this. This is actually the rate that it increases by. So for example, I say that on the first day, well, at the beginning of time, whatever time it could be today or whatever, on the 0th day, I have 2 to the 0th power. Please remember, that will be 1. Any number to the 0th power equals to 1. It's very important. Please remember that. All right, so on the 0th day, how much money do I have in the bank? $100. But this bank is like kind of bad. They're like losing money. They're not very good at math. It's because like every day, it doubles your money. Look at this. This is called the rate. Okay, we're gonna go further into that later. This is the rate that increases. I said that it doubles. Doubles is you get the original 100% is whatever you have, and it gives you an additional 100%. So this is 100%. In numerical value, it's 1. And then you get another 100%, that's 2. Well, 200%, but it's literally just 2. So you put that in there. There's a reason I'm teaching you this. Okay, now, so on the first day, 2 to the first power times 100. Guess how much money I will have? I double the money. And on the second day, obviously 2 squared, it's now 400. On the third day, whoa, you have $800. You can see that these numbers increases exponentially, times 2, times 2, and times 2. And then you can see that this one doesn't. Okay? This one doesn't. This one increases linearly. Okay? And then this is a cubic function that it increases whatever it is, x to the 3rd power. Okay, so that makes it, well, anyway, this one makes it an exponential function because the x is in the exponent. When do we need to use this? It's kind of like the function that we actually see every day, right? The bank interest is the most understood one without much help. Let's just say that the bank gives you 6% every year, and then originally you have $1,000. After 10 years, how much would you have? So y equals to 1,000. You first start with 1,000. Every single year you get 6%. So at the end of the first year, you will keep your original 100% of this money, and then you will get an additional 6%. Okay? It's 10 years on top of that. And then you will see that this function is the exponential function because it increases exponentially. What I mean is that, okay, after the first year, you will have this much money. So if you do the next y, let's do x here. After the first year, this is the amount of money that you have. Now, after the second year, you actually have this amount, the original amount, now times 1.06. So this additional $60 will make this interest as well. That's why interest is so good. Stock market is very interesting. So we can talk about that later. But what I'm trying to say that now, the first additional money that you have made can now earn more money. That's called a compounding interest. So with this, whatever this number is, it's gonna be like 200 and like maybe 2,000, and let's just say it has to be maybe 140, maybe something like that. You can see that every year, at the first year you made additional $60, but the second year you made a little bit more. You made about $80, the difference, because this additional 6% is applying to the extra money that you have made. What I'm trying to tell you is that these exponential functions in general have a form. The form is this. This is how many times how many times the growth has occurred. So for example, if you leave your money in a bank for 10 years, there will be 10 times. This is how much, it's either time or how many times. You understand that in a second. And then this is your original, how much you have. And this is the rate of increase. So if it's doubling, it's just 1 plus 1, right? If it's increasing additional 10% every year, it will be 1 plus 0.1. And then if it's decreasing, for example, if it's decreasing 10% or 20% each year, it will be the original 100%, and then you minus 20% every year. Okay, that actually happens a lot as well. Let me give you an example of that. Certain things decrease exponentially. Let's talk about the fish in the ocean. Let's just imagine there is 1 million tons of fish in the ocean, but we overfish it because we really like fish, and tuna can be sold for a lot of money. We lose 1% of our fish every year. We lose 1% of our fish every year. So with this function, we will be able to tell how much fish we will have left. Now this is obviously 0.99%, and then this is x. This is how many years. So if now you could see the screen, I'll put that into Desmos, and then you'll be able to tell that it is actually it decreases exponentially. So 1 million, this one more zero, yeah. And then 99 to the power of x. Oops, not that one. Power of x. Okay. Let me zoom out a little bit because we started 1 million. Look, it started high, it went all the way down. Now, what does this chart mean? So let's take a look. If we lose 1% of our fish every year, 100 minus 1, on the, let's just say this day, 650th year, we will only have 1,500 tons of fish in the ocean. You can see that this graph decreases exponentially. It went from really, really high and all the way down. If the rate is an increasing rate, so for example, if we no longer overfish our fish, they reproduce themselves, and now you can see that our fish now increases because it increases 1%. Obviously, it is impossible to go back in time but you will have to look past the x-axis. It's too high, so I'm not going to go over there. Okay, so there is one thing I want to clarify. Let's graph it really quickly. You already saw it on Desmos for a quick moment. Let's just take a look at this function. If x equals to 1 times, and then the rate is doubling. You're doubling your amount every single time. Let's do an XY chart. If it's 0, you will get 1. If it's 1, you get 2. If it's 2, you get 4. However, if it's negative 1, what do you get? Please don't forget, you learned this last unit. This 2 to the negative first power is 1 over 2. 2 is placed at the bottom, so it's 0.5. If it's negative 2, 2 to the negative second power, it'd be 1 over 4, 0.25. If you graph this, at 0, it'd be 1. At 1, it'd be 2. At 2, it'd be 4. But negative 1, it'd be half. And then negative 2 would be this. This is an exponential growth function. It goes up instead of linearly, exponentially. Okay? Now, I would like you to try this. Please draw this function. Let's just say you have $1 every day, but you lose half of it every day. Please pause the video and graph this function. All right, when you're done, make sure you do an XY chart. 0 will be 1. 1, it would be half. If it's negative 1, please notice this. Negative 1, what is this to the negative half, to the negative first power? It would be 2. So that's 2. And if it's negative 2, it would be 4. Now, the answer will hence look like this if you actually put it in a graph. This is something called the exponential decay function. So at the end of 7.1, you will learn one thing. You will learn one thing is that if this number is greater than 1, doesn't matter what this number is, doesn't matter what this number is. If this number is greater than 1, it will always have an exponential growth. If this number is less than 1, it will always be exponential decay. All right.